Hey ladies, so today we're doing section 9.2 and we are analyzing rational functions. So one thing that we've been doing almost throughout this whole course is we've been looking at different features of different types of graphs. And to be a little bit more specific along this unit, graphs of rational functions can have a variety of shapes and different features. One that we've looked at last section was vertical asymptotes, and those correspond to a non-permissible value in the equation of the function. So that's when your denominator, or what we would know as, it would be when your denominator is equal to 0. But what's not going to be the case is, not every non-permissible value will be a vertical asymptote. So what it will actually result in is a point of discontinuity. So you guys might remember, I think I kind of briefly mentioned this word last section. And so a point of discontinuity, this is just usually described as an ordered pair, and this is where the graph is not continuous. These usually occur in rational functions when its function can be simplified by dividing the numerator and the denominator by a common factor that includes a variable. So that's a big key point here, is that it can be divided by a common factor which it includes a variable. So looking at the graph, here we have one to the right here. Here we have a non-permissible value, and this one's at 3 and 1. And what this, we can also give the point of discontinuity. This also has a different name, and we say that it looks like a hole. So it looks like a hole in the graph, and we usually represent it by an open circle, or make it look like a hole in the graph. And so basically, like, what point of discontinuity will do is your graph will behave the exact same way as it normally would, but then there's this just hole. So you guys remember with say with asymptotes, there's a point where this graph cannot reach, and what would happen is that your graph would approach it but would never actually touch that point, right? So it changed the behavior of it. So this one, it will still act as say a linear function, and but it just kind of does a little jump over that point and then continues on. Okay, so there's going to be 3 different cases that we're going to be looking at. So the first one is when we have just asymptotes, so when there's no common factors. Okay, so no common factors is when we'll have an asymptote, and that's no common factors with the denominator. Okay, so what we're going to do is we're going to take this equation here, and we're going to rewrite that into standard form. If you guys remember, that is y is equal to a over x minus h plus k. And we did do a question like that last section, so hopefully this will be a good reminder. So what we're going to do is we want to make our numerator have or look something like our denominator. So we need to add and subtract by the same number, so that way we can pull out this common factor. So if you guys notice, we have x minus 3. So what we're going to do is we're going to have x minus 3 plus 3, and this will cancel it, so we're really not changing the numerator, we're just rewriting it to look different. And then plus 4, that's all divided by x minus 3. Then we group our factors together there, so we have y is equal to x minus 3, and then 3 plus 4 is 7 over x minus 3. Then what we'll do is we'll split up our fraction, so we can do that with the numerators. I'm just going to write this over here, so we have y is equal to x minus 3 over x minus 3, and then we have 7 plus 7 over x minus 3. Then from there, we'll cancel out. Those two will divide to be 1, and we can reorder it at the same time if you ladies don't mind. So what we'll have is 7 over x minus 3, and x minus 3 divided by x minus 3, that is just equal to 1. Okay? And one point is, if you guys remember once again, what value is your horizontal asymptote? Given our standard form a, divide that by x minus h plus k. So which value there, if you remember, which one was the vertical asymptote, or sorry, the horizontal asymptote? So if you guys remember, this one here is your k value. So if k is equal to 1, that means that your horizontal asymptote will be at y is equal to 1. Okay, so moving on. Our second option here is that we have just a point of discontinuity. So what that means is that we have at least one common factor. So here I gave you a nicely factored function there. And if you guys notice there that there is x plus 2 in the numerator and the denominator. So that means that they cancel out. So what you're going to be left with is y is equal to x minus 4. So what you would do here is that you would graph y is equal to x minus 4, but then you take this canceled out term and you have to set that one equal to 0. So you'd have x plus 2 is equal to 0. Then where we would have a hole is at x is equal to negative 2, so solve for x. So even though they were able to cancel out, we still actually, in the original function, we have this non-permissible value there. And that in itself will affect the graph, and it will give you a hole or a point of discontinuity, which I usually label as POD, and that there is equal to negative 2. So if you guys even try putting this into your graphing calculators, and your graphing calculator may not show this hole, but if you open up the table of values, if you go to x is equal to negative 2, it should come up as undefined. Okay? So just as a pointer again, so it'll act as this linear function y is equal to x minus 4, but it'll have that hole at x is equal to negative 2. Alright, so then our third option that we can move on down to is what happens when we have both an asymptote and a point of discontinuity. So looking at this fully factored function here, if you guys notice here, we have common factor of x plus 2. So those ones will cancel out, and what we'll be left with is y is equal to x minus 4 over x minus 1. So to find your point of discontinuity, this one you don't have to do much work. This one you just have x plus 2 is equal to 0, and then once again solve for x, and you have x is equal to negative 2. So with point of discontinuity, look at that common factor. Set that equal to 0, and that's where your hole will be. So to find your asymptote, we're going to do the same few steps that we did in our first one. So we're going to change this back into our standard form, y is equal to a over x minus h plus k. From there it'll be really easy to see where this value is, because we'll know what k is, and we can go from there. So here we have y is equal to x minus 4 divided by x minus 1. So if we want to get that into standard form, remember, we want to rearrange, or we want to manipulate our numerator to make it look like that denominator. So we'll have y is equal to x minus 1 plus 1, so that'll equal to 0, so you'll still have that same numerator, it just looks different. And then subtract 4, that's divided by x minus 1. Grouping those together, we have x minus 1 minus, that'd be 1 minus 4 is negative 3 over x minus 1. Breaking up that numerator, we have y is equal to x minus 1 over x minus 1 and negative 3 over x minus 1. Canceling these two terms out and then rearranging, we have y is equal to negative 3 over x minus 1 plus 1. And once again here what we'll see is that here our k value. K is equal to 1, so that means our horizontal asymptote will be at y is equal to 1. So now one thing that I just want to add on here is we also stated that our point of discontinuity, it is usually it's often represented as a coordinate. If you left it as x is equal to negative 2, I would personally be fine with that, but if you wanted to, if you want to stick with I guess what the definition of a point of discontinuity is, then let's definitely give it as a coordinate. And so take a quick second, which equation would you put x is equal to negative 2 in to find that coordinate? So what would happen if you put it into, say, y is equal to, I guess this original function here. So if you notice, you'll have a 0 in the numerator and a 0 in the denominator. So that isn't going to get you anywhere. And so what we're going to end up doing is you're going to put it into the simplified function and find out what y is equal to. So here we have y is equal to, so substitute in negative 2 in for x, we have negative 2 minus 4 divide that by -2 minus 1. -2 minus 4 is -6. -2 minus 1 is -3. And what we have there, y is equal to 2. And then writing that as a coordinate, we have x is equal to -2 and y is 2. And that is where our point of discontinuity is. So now we're getting close up into our time range there, so I'm not going to move on to the next example. We're going to do that in video 2. And so one thing that I will encourage you ladies, while the next video is loading, try either, or at least try to graph it, the next one. But if not, think about how you would graph it. So just as a hint there, so first you're going to simplify this function here. So factor the numerator and see if there's any common terms. And then you're going to graph the equation that is left over. And then just keep in mind that you're going to have a hole, so figure out how you're going to set this up to include that hole, okay? So I'm going to stop the video so you guys can move on to number 2. But I do encourage you guys to try this one first. And for the first example, please do this one by hand, just so I can make sure that we've got graphing down for each section. But then say, for example, number 2, you are more than welcome to do that one using your graphing calculators, okay?